Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 14, Equation of a Line. We will be studying some new concepts and solve many questions from exercise 14b. Hope you all are ready with your pen and papers. Let's begin. First concept is inclination of a line. Inclination of a line is the angle theta which the part of the line above x-axis makes with x-axis. Consider the coordinate axis. Here we have x-axis and this is our y-axis. And this point will be origin. Now, I am considering a line. This is my line. Okay. This line, it makes some angle with x-axis. Yes. From x-axis, it has moved some distance. Yes. It has moved some distance. So, this angle we represent as theta. From the line towards the right side, along the x-axis, the angle measured, this angle is called inclination. This theta angle is called inclination. Understood? Always measure towards the right side of the line. You cannot measure to this direction. This is not inclination. This towards the right side of the line, the angle measured is called inclination. Now, if I am taking this inclination, I am measuring the angle like this, that is anti-clockwise. Okay, if I am measuring anti-clockwise, then we say that the inclination is positive. Inclination is positive. That is, we are measuring in the anti-clockwise direction. You know the clockwise and anti-clockwise direction. In which direction the clock, the needles in a clock rotate. We know this direction is clockwise direction and the opposite is anti-clockwise direction. So, this measurement, this is an anti-clockwise direction. So, when you measure in anti-clockwise direction, the inclination is positive. Now, if you are taking this line and measuring like this, okay, this is clockwise direction. In the clockwise direction, if you are measuring the inclination angle, then the inclination is negative. Okay, understood what inclination is? So, the angle it has raised from the x-axis. With respect to x-axis, what angle the line has raised? Clear? It is represented by theta. Now, we know what inclination is. Let us see for lines parallel to x-axis and y-axis, what is the inclination? Here, we will take some points. 1, 2, 3, 4. Along x-axis, 1, 2, 3. Minus 1, minus 2, minus 3. Okay. So, here I am taking a line that passes through this point. Here the coordinates of this point are x coordinate will be 0 and y coordinate is 1. 0, 1. A line is passing through the coordinates 0, 1. This line, when you consider this line, it is not intersecting the x-axis, but it is parallel to the x-axis. Yes, a line that is parallel to x-axis. What is the angle theta here? What angle does it make with the x-axis? 0, right? Correct. The angle it makes with the x-axis is 0 degree. Which means, when you take other lines also that is parallel to the x-axis. For any line that is parallel to x-axis, you will be getting theta equal to 0 degree. Clear? Now, if you are taking lines that are parallel to y-axis. Here I have 1, 2, 3. This is minus 1, minus 2, minus 3. Again 1, 2, 3, 4. Line parallel to y-axis, which means I take a point 1 here. Here the x coordinate is 1 and y coordinate is 0. 1, 0. This is a point. I'm taking a line that passes through this 1, 0. So, along this line, the x coordinate will be 1. This is x is equal to 1 line. X coordinate will be 1. Y can take any value. So, this is a line that is parallel to the y-axis. Again, this is a line that is parallel to y-axis. Equation is x is equal to 2. This is also a line that is parallel to the y-axis. Here the equation is x is equal to 3. So when you consider this line, what is the angle made by these lines with the x-axis? See, this is the angle which it makes with the x-axis, which means the angle is 90 degree. Angle is 90 degree. So when you take lines parallel to the y-axis with x-axis, it makes 90 degree. They are perpendiculars. Okay, here the theta angle is equal to 90 degree. So we can conclude that inclination theta of the x-axis and every line parallel to the x-axis is 0. You take x-axis or any line parallel to x-axis, the angle theta will be equal to, inclination theta will be equal to 0 degree. And inclination theta of the y-axis and every line parallel to the y-axis is 90 degree. This angle 90 degree. That is a line which is parallel to y-axis or the y-axis will make an angle theta equal to 90 degree with the x-axis. Understood? Perpendicular and parallel cases. Now let's understand the concept of slope. Slope is also known as gradient. Here I am considering a horizontal distance. We know what inclination is. Inclination is the angle. It moved from the x-axis. Now here up to this height, this is called the vertical rise. Vertical rise. And this is the horizontal distance. Horizontal distance. So a plane starting from here has rise to this vertical height. This plane will take as the inclined plane. Inclined plane. And the angle it moved is our inclination. Theta angle, inclination. Now to understand slope, the slope of any inclined plane is the ratio between the vertical rise and the horizontal distance. It is a ratio of vertical rise and the horizontal distance, vertical rise. So for this angle theta, we'll be taking slope is equal to vertical rise divided by horizontal distance. Horizontal distance. Okay. Now let us take this as a right angle triangle ABC. Okay. Then slope is equal to vertical rise. Vertical rise, what is vertical rise here? It is AC. AC divided by horizontal distance. Horizontal distance is BC. Okay. This base of the right triangle and height of the right triangle. We have studied in trigonometry, sine of some angle theta is equal to opposite side divided by hypotenuse. Cos of angle theta is equal to adjacent side divided by hypotenuse. So here we are considering this angle theta, which is our inclination. This is the opposite side. This is adjacent side. And this longest side of the right triangle is the hypotenuse. Here sine of theta will be opposite by hypotenuse. Cos of theta is adjacent by hypotenuse. Then what about tan theta? Tan theta is the ratio of sine theta and cos theta. Sine theta by cos theta is equal to tan theta. So dividing, you will be getting opposite side divided by adjacent side. Tan theta will be equal to opposite by adjacent. Okay, here opposite is AC and BC is the adjacent side. Therefore, we have got slope is equal to AC by BC and that is equal to tan of angle theta. AC by BC, that is vertical rise by horizontal distance is here the tan theta. Therefore, we can write slope or gradient is equal to tan theta. This is how you will be getting a slope. You have an inclined plane here. The slope of this inclined plane or inclined line will be tan of angle theta, and theta is the inclination. Understood? If this angle theta is 30 degree, theta equal to 30 degree, then what is the slope? Slope is equal to tan of 30 degree. What is the value of tan 30 degree? Tan 30 degree is 1 by root 3. That is 1 by root 3. Okay. If theta is equal to 60 degree, what if theta is equal to 60 degree? We get slope is equal to tan of 60 degree. What is the value of tan 60 degree? Tan 60 degree is root 3. Okay. This is how you can find the slope using the inclination theta. Clear? Let us discuss the slope or gradient of a straight line. We know what straight line is. The slope of a straight line is the tangent of its inclination and is denoted by letter M. Using letter M, we represent the slope. Now, if you are taking the slope of x-axis, this is x-axis. What is the slope of x-axis? For x-axis, we have discussed angle theta will be equal to 0 degree. Inclination, there is no inclination, right? For a x-axis or any lines parallel to the x-axis, angle theta will be equal to 0. In that case, inclination theta is equal to 0. Then slope represented by letter M, which is equal to tan theta, will be tan of 0. What is the value of tan 0? Tan 0 is 0. Okay. So, the slope of x-axis or any line parallel to x-axis will be equal to 0. Now, what about slope of y-axis? Y-axis we have said are perpendicular to x-axis. Y-axis is perpendicular to x-axis. Any line parallel to y-axis will also be perpendicular to the x-axis. Yes? So, this is a line which is parallel to y-axis. It is perpendicular to x-axis. This is y-axis. It is perpendicular to x-axis. Here, what is the angle? Angle theta is equal to 90 degree. For a line parallel to y-axis or the y-axis, inclination theta is equal to 90 degree. In that case, if theta equal to 90 degree, what is slope M? M will be equal to tan of 90 degree. Tan theta, tan of 90 degree. What is the value of tan 90 degree? Tan 90 degree is not defined. Okay. Tan 90 degree is not defined. Next, how do we get positive slope? When does slope becomes positive? Now take a case. I am considering a line. This is a line. So we measure inclination in the anti-clockwise direction. Then we get positive inclination, right? Here, let us take this angle as some 45 degree. Here the inclination is 45 degree. In that case, what is the slope? Slope M. If theta is equal to 45 degree, slope M is equal to tan of 45 degree, and that is equal to 1. This is a positive value and hence it is a positive slope. That is, when you are measuring with respect to x-axis in the anti-clockwise direction and we have an acute angle. What is acute angle? 45 degree is an acute angle, which means angle less than 90 degree. We call them acute angle. So, in case of acute angle, if the inclination is an acute angle, theta is an acute angle, in that case, we get positive slope. Okay. Now, when do we get negative slope? Let's see. Here I am considering a line. Okay. When I measure this angle in the anti-clockwise direction, let us take this is some 135 degree. So, here we have a 135 degree. I am measuring in the anti-clockwise direction. Is this an acute angle? No, right? This is an obtuse angle. What is obtuse angle? Angle greater than 90 degree and less than 180 degree we call as obtuse angle. So, this is an obtuse angle. In case of obtuse angle. Now, this measurement we got, it is 135 degree. So this is a straight line. The total measurement will be 180 degree. Then what is this part? This part will be equal to 45 degree. That is, from the left side of the line along the x-axis, when you measure the angle in the clockwise direction, we get 45 degree. So this case we have to take it negative. Yes, we have discussed theta is taken or inclination is negative when the measurement is in the clockwise direction. When measured in the anti-clockwise direction, we will be getting theta positive. Here, our theta angle is equal to either minus 45 degree or theta is equal to 135 degree, which is an obtuse angle. We will be getting m is equal to tan of minus 45 degree. And that is equal to minus tan 45 degree, which is minus 1. Here we have got a negative slope. So, we will be getting negative slope when the angle measured with respect to the x-axis in the anti-clockwise direction is an obtuse angle, or measured in the clockwise direction from the left side of the line along the x-axis is an acute angle. We get slope negative. Clear? Any angle, here we have taken the example for 45 degree and 135 degree. Any angle which is an obtuse angle will be getting slope negative. Any angle which is an acute angle and measured in the anti-clockwise direction, we get positive slope. Is the idea clear? So, let's conclude this. For x-axis, angle theta will be equal to 0. Therefore, slope will be equal to tan of the angle theta, tan of 0, and that is 0. Y-axis, every line parallel to y-axis is perpendicular to the x-axis. Therefore, angle theta is 90 degree. In that case, we will be getting slope as not defined. We get positive slope when the measurement is done. The inclination is an acute angle and measured in the anti-clockwise direction. We get negative slope when the angle measured is an obtuse angle with respect to the x-axis in the anti-clockwise direction, or acute angle measured in the clockwise direction, that is to the left of the line along the x-axis. Clear? We get negative slope in that case. Next, the slope of a straight line passing through two given fixed points. We know to find the slope when inclination or angle theta is known. In the case when we only know 2 points which are lying on the straight line, we don't know the angle theta. In that case, how to find the slope of the straight line? Here I am considering a straight line. We'll take 2 points. This is my first point P of coordinates x1, y1. And this is my second point Q of coordinates x2, y2. Okay. Here we have an angle. What is this angle? This angle is the inclination. Yes. Angle theta. Now, let me take a straight line parallel to the x-axis. Okay. Consider these two lines. This is my x-axis and here I have a line which is parallel to x-axis. When you consider this line, this is a line transversal which cuts both the parallel lines. Yes. So, when the transversal cuts parallel lines, what do we get? The corresponding angle should be equal. So, this angle is some theta. Because when this angle is theta, this is a corresponding angle and it should be equal to theta. Now, here for this point P, it has moved x1 distance along the x-axis and y1 distance along the y-axis. Then, when you take the point Q, Q has moved x2 distance along the x-axis and y2 distance along the y-axis. Here, I'll mark some O. Okay. Consider this triangle POQ. We understand that this is a right triangle. Let us find the tan of angle theta. What is tan theta? Tan theta is opposite side divided by adjacent side. For this angle theta, what is the opposite side? Here we have QO. QO is the opposite side. Adjacent side, angle touching side. This is PO. We have adjacent side, PO. Now, what are the measures of QO and PO? What do we get the measures? Here, for this point P, this distance is Y1. Yes, this distance is Y1 and this distance is X1. Here, we need PO. The coordinate of this point is X2, 0, and that of this point is X1, 0, which means this distance will be equal to X2 minus X1. Here we have total X2, X1 is subtracted. We get X2 minus X1. Now, what about this part? What about this part? The total height is Y2. Q is at a distance of Y2 and P is at a distance of Y1, which means this part will be equal to Y2 minus Y1. Okay, here we have X2 minus X1, therefore PO will be equal to X2 minus X1. Here we have Y2 minus Y1. QO is equal to Y2 minus Y1. Substituting, we get tan theta is equal to QO is Y2 minus Y1 divided by X2 minus X1. Okay, we know M is the slope. Slope M is equal to tan theta and that is Y2 minus Y1 divided by X2 minus X1. So, in the question, if the inclination is not given, in that case, take 2 points. If you know the coordinates of these 2 points, taking the points as X1, Y1 and X2, Y2, we can easily find the slope with this formula, that is M is equal to Y2 minus Y1 divided by X2 minus X1. Understood? So, we can conclude that slope M is equal to difference in ordinates of the given points. Ordinates means Y coordinates. Y2 minus Y1. It is the difference of the Y coordinates divided by difference of their abscissa. Abscissa X coordinates. Difference of X coordinates. X2 minus X1. Therefore, slope M is equal to difference in ordinates of the given points divided by difference in abscissa of the given points. M is equal to Y2 minus Y1 divided by X2 minus X1. Clear? So, to find the slope of a straight line passing through 2 given points, we can take this formula. If inclination is given, we will take the other formula. That is, M is equal to tan theta. Just we have to substitute the value of theta. When the value of tan theta will give us the slope. Let us consider parallel lines. Here, we have the coordinate axis and 2 lines are given. I am taking the first line as AB and the second line as CD. Okay, these are parallel lines. Let the inclination angle of line AB be equal to theta and CD, the angle is alpha. Okay, here for this parallel lines, x-axis is a transversal, right? X-axis cuts both the lines. And these lines are parallel lines. AB is a line parallel to CD. And x-axis in this case is the transversal. So, when a transversal cuts parallel lines, we will be having the corresponding angles equal. Here, alpha and theta are the corresponding angles, which means we can say that theta is equal to alpha. Yes, theta is equal to alpha. Let us take the slope of AB equal to some M1 and the slope of CD as M2. We are going to find the relation between the slope of AB and slope of CD. We have theta is equal to alpha. Then what about tan theta? Tan theta will be equal to tan alpha. If they are same angle, then tan theta will be equal to tan alpha. We know that slope M is equal to tan of angle. Therefore, M1 will be equal to tan of theta and M2 is equal to, that is slope of CD will be equal to tan of alpha. Yes, tan theta is equal to tan alpha, which means M1, tan theta is M1 will be equal to M2. What can we conclude from this? Slope of AB is equal to slope of CD. Yes, the slope of parallel lines will always be equal. This is the conclusion. If two lines are parallel, their slopes are equal. Now the converse of this, if the slopes of two lines are equal, the lines are parallel to each other. First statement, just the opposite statement, we have the second. If you are given two lines and it is said that these two lines are parallel, in that case, the slope of these lines should always be equal. Second statement is, if it is given that the slopes of two lines are equal, then surely these two lines will be parallel. Here, we have discussed about the slope of parallel lines. Now, let us take the case of slopes of perpendicular lines. I am taking two lines. This is my first line AB at an inclination angle theta. And this is my second line CD at an inclination angle alpha. Okay. Let us take the slope of AB equal to M1 and slope of CD as M2. These two lines are perpendicular to each other. Now, slope of AB will be equal to tan of that angle. Here for M1 slope, we have angle inclination theta, which means M1 will be equal to tan of that angle theta. And M2, slope of CD, inclination here it is alpha. M2 will be equal to tan of alpha. Okay, now consider this triangle ABC. This is an exterior angle. Okay, we have a property exterior angle is equal to sum of the opposite interior angle. Okay, here we have theta is the exterior angle. It will be equal to the sum of internal opposite angle. These are internal opposite angle. We have alpha and 90 degree. Therefore, theta will be equal to alpha plus 90 degree. Taking tan of theta will be equal to tan of alpha plus 90 degree. What is tan alpha plus 90 degree? In trigonometry, we have studied a property. Tan of alpha plus 90 degree is equal to minus cot alpha. We can write tan theta is equal to minus cot alpha. Okay. Also, we have, what is the relation connecting cot and tan? Cot theta is equal to 1 by tan theta. Yes. Therefore, cot alpha will be 1 by tan alpha. We can write tan theta is equal to minus 1 by tan alpha. On cross multiplying this, we get tan theta into tan alpha will be equal to minus 1. What is tan theta? Tan theta is the slope of AB, M1, into tan alpha is the slope of CD, M2. M1 into M2 is equal to minus 1. Okay, that is the product of slopes of two perpendicular lines will be equal to minus 1. We can conclude, if two lines are mutually perpendicular, the product of their slopes is minus 1. Okay, now the reverse thing. If the product of the slopes of two lines is minus 1, the lines are mutually perpendicular. Clear? If M1 and M2 are the slopes of two lines which are mutually perpendicular, then M1 into M2 will be equal to minus 1. In case of parallel lines, we got equal slope. M1 is equal to M2. Here we have M1 into M2 is equal to minus 1. Got it? We have all the concept in our hands. Now let us take an example. Find the slope of a line segment whose inclination is. Three angles are given. When angles are given, we know to find the slope. We have slope M is equal to tan of inclination angle theta. In the first question, we have angle 60 degree. Then what is slope? M is equal to tan of 60 degree. M is equal to tan 60 degree is root 3. Okay. M is equal to root 3. Now the second one, angle theta is equal to 0 degree, which means slope m is equal to tan of 0 degree. M is equal to, what is tan 0 degree? 0. Here we get slope 0. That is the case of x-axis or line parallel to the x-axis. Now the third one, angle theta is equal to 45 degree. Then what is the slope? Slope m is equal to tan of 45 degree. What is tan 45 degree? 1. Therefore, m is equal to 1. For 60 degree, we got slope m is equal to root 3. For 0 degree, we got slope m is equal to 0. And for 45 degree, we got slope m is equal to 1. Next, example 2. Find the slope of the line passing through the points a minus 2, 3 and b, 2, 7. Also find the inclination of the line AB. Second, slope of the line parallel to AB. And the third, slope of the line perpendicular to AB. Here first, we have 2 points given, A and B. Coordinates of point A are minus 2, 3 and that of B are 2, 7. How to find the slopes in 2 points? 2 fixed points are given. This is a line connecting A and B. We have slope m is equal to y2 minus y1 divided by x2 minus x1. Here the coordinates of the first point will take as x1, y1 and that of second point will take as x2, y2. Substitute the values. We get m is equal to y2 minus y1. Here y2 is 7 and y1 is 3. 7 minus 3 divided by x2 minus x1. x2 is 2 and x1 is minus 2. Minus of minus 2. That is equal to 7 minus 3, 4 divided by 2 minus of minus 2, 2 plus 2 which is 4. That is equal to 1. We got the slope m is equal to 1. Now what is the first question? We need to find the inclination of the line AB. First question, we need to find inclination theta. We have slope m is equal to 1 which means tan theta. M is equal to tan theta and tan theta is 1. Okay, when do we get 1? Tan theta is equal to tan of which angle do we get 1? Tan 45 degree. Correct. Tan 45 degree, which means the inclination theta will be equal to 45 degree. Inclination theta is equal to 45 degree. Only when the angle is 45 degree, we get the slope m is equal to 1. Now the second question. Slope of the line parallel to AB. In case of parallel lines, we have discussed slope will be same. Yes. Therefore, slope of line parallel to AB is equal to slope of line AB. In case of parallel lines, they will be having equal slopes. If slopes are equal, then these two lines will be parallel. Therefore, we have the slope of line parallel to AB equal to slope of line AB. Slope of line AB we have determined, which is 1. Slope of line parallel to AB is also equal to 1. Now the third question. Slope of a line perpendicular to AB. Let us take the slope of line AB as m1. m1 is equal to 1. And the slope of line perpendicular to AB is taken as m2. We have m1 into m2 is equal to minus 1. If two lines are perpendicular, then the slope, the product of the slopes will be equal to minus 1. Here we have m1 as 1 and m2 we don't know, we need to determine m2. m1 into m2 will be equal to minus 1, which implies m2 is equal to minus 1 divided by 1, and that is minus 1. Therefore, slope of line perpendicular to AB is equal to minus 1. Slope of line perpendicular to AB is equal to minus 1. Clear? So here first we have determined the slope of line AB. Then using the slope we have determined the inclination theta. Third, we have determined the slope of a line which is parallel to AB. And then we have determined the slope of a line which is perpendicular to AB. Clear? Next is the condition for collinearity of 3 points. 3 points are said to be collinear if they lie on the same straight line. Let us take a straight line. And I am taking 3 points A, B and C. Okay, these 3 points lie on the same straight line. Now, we'll be discussing about the slopes of different lines. Here we'll have AB is one part, BC is one part, AC is another part. Okay, let us take some coordinates. A is 1, 1, B is 2, 2 and C is 3, 3. Okay, we'll take the slope of AB as M1. Okay, how to find slope when 2 points, the coordinates of 2 points are given? We have slope M. Here M1 is equal to y2 minus y1 divided by x2 minus x1. Yes, here we have 2, 2, x2, y2 is 2, 2 and 1, 1 is x1, y1. Putting values we get 2 minus 1. y2 is 2 and y1 is 1 divided by 2 minus 1. 1 by 1 equal to 1. We got M1 is equal to 1. Next, the slope of BC. What is the slope of BC? How to get slope of BC? We'll be taking slope of BC as some M2. M2 is again equal to y2 minus y1 divided by x2 minus x1. Here we'll be taking y2, x2, y2, this point C, and the coordinates of B is taken as x1, y1. In that case, we get y2 minus y1. Here we have 3 as y2 and y1 is 2. 3 minus 2 divided by, again x2 is 3 and x1 is 2. 3 minus 2 equal to 1 divided by 1, which is again 1. We got M1 is equal to 1 and M2 is equal to 1. Now, let us take the slope of AC. I am taking slope of AC as some M3. Okay, what is M3? M3 will again be equal to y2 minus y1 divided by x2 minus x1. Here in this case, I am taking the coordinates of A as x1, y1 and coordinates of C as x2, y2. Here, what is y2 then? y2 is equal to 3 and y1 is equal to 1. 3 minus 1 divided by x2 is 3 and x1 is 1. 3 minus 1. 3 minus 1 is 2. Here again 3 minus 1, that is also 2. 2 by 2, 1. We got M3 is also equal to 1. So, in case of collinear points, when you find the slope, since they lie on the same straight line, we'll be getting, considering 2 points, we'll be getting slopes equal. If you find AB, slope of AB will be equal to slope of BC and that will be equal to slope of AC. It is not necessary that A, B, C like this. Sometimes B can come here. Okay. In any case, the slope of points taken and determined will be getting the slope of any 2 points will be equal to the slope of other 2 points when these points are lying on the same straight line. Clear? So, these 3 points are called collinear points. Collinear points are points which lies on the same straight line. Understood? Let us take an example related to the collinear points. Given the points A, 2, 3, B, minus 5, 0 and C, minus 2A are collinear. Find A. Here we have 3 points A, B and C. The coordinates of A are 2, 3. That of B are minus 5, 0 and that of C are minus 2A. It is said that these 3 points are collinear. First, let us take the slope of AB. If they are collinear, then the slope of AB should be equal to slope of BC, and that should be equal to slope of AC. We are taking slope of AB as some M1. Then what is M1? M1 will be equal to Y2 minus Y1 divided by X2 minus X1. So, for the points A and B, here we will be taking this as X1, Y1 and this as X2, Y2. Okay. Then what is the value? Y2. Y2 is 0 minus Y1 is 3. 0 minus 3 divided by X2 minus X1. X2 is minus 5 and X1 is 2. Minus 2, which is equal to 0 minus 3 is minus 3, minus 5 minus 2 is minus 7, equal to 3 divided by 7. This is the slope M1. Next, let us take the slope of BC. BC. Here, in that case, we will be taking x1, y1 as the coordinates of B and x2, y2 coordinates of C. M2 is equal to Y2 minus Y1. Here in position of Y2 we have A. A minus Y1 is 0. Divided by X2 minus X1. X2 is minus 2 and X1 is minus 5. Minus 5. Equal to A minus 0 is A divided by minus 2 minus of minus 5. Minus 2 plus 5 which is 3. Okay, since these points are collinear, slopes should be equal. Slope of AB should be equal to slope of BC, which means M1 is equal to M2. Implies, what is M1 value? We have 3 by 7 equal to M2. M2 is A by 3. From this, we are going to find the value of A. Implies A is equal to, cross multiplying, 3 into 3 divided by 7. The value of A is equal to 9 divided by 7. Yes, 3 into 3 is 9 divided by 7. So, converting to the mixed fraction from improper fraction, we get 7 goes 1 time in 9, 2 is the remainder and the denominator is 7. 1, 2 by 7 is the value of A. Okay, so the coordinates of point C. Minus 2, 1, 2 by 7. Got it? So here we have 3 points. These are collinear. Therefore, the slopes should be equal. M1 is equal to M2, from which we have determined the value of A. Let us now solve more problems from exercise 14b. Here we have the first question. Find the slope of the line whose inclination is, first question 0 degree and the second 30 degree. What is inclination? Inclination is theta angle. In the first question, we have theta is equal to 0 degree. We have slope represented with letter M is equal to tan of theta, tan of the inclination. Here we have tan theta is equal to tan 0. That is slope M is equal to tan 0. What is the value of tan 0? Tan we know, tan is equal to, tan theta is equal to sin theta divided by cos theta. Yes, sin theta, the value of sin 0. Here we need tan 0. Tan 0 is equal to sin 0 by cos 0. If you don't remember the value, you can get the value from sin and cos. We are studying the sin 0 is equal to 0 and cos 0 is equal to 1. Sin 0 is 0 and cos 0 is 1, which means tan 0 is equal to 0. Yes, tan 0 is 0. Therefore, slope M is equal to 0 for the first question. Okay, now the second, we have inclination theta is equal to 30 degree. What is tan 30 degree? Tan 30 degree is equal to sin 30 by cos 30. If you have studied all the trigonometric values, then it will be easy. Only if you have studied sin and cos, from that we can get the value of tan 30. Sin by cos is 10. Okay. What is sin 30? Sin 30 is 1 by 2 divided by cos 30. Cos 30 is root 3 by 2. Root 3 by 2. Taking the reciprocal of the denominator part and multiplying, we get 1 by 2 into 2 by root 3, which is equal to 1 by root 3. Okay, therefore, here slope m is equal to tan of the angle theta, which is tan 30 degree. What is the value of tan 30 degree? Tan 30 degree is equal to 1 by root 3. Therefore, slope m is equal to 1 by root 3 in the second question. Clear? Now, if you have tan 60, that is inclination is 60 or inclination is 45, whatever angle it is, you can easily find. Clear? Next, the second problem, question 2 of exercise 14b. Find the inclination of the line whose slope is first 0 and the second root 3. Here, in this question, inclination we need to find and the slope is given. In the previous question, inclination was given and we found out the slope. Let us see how to find the inclination with slope. The reverse we have to do here. For that, we'll first study some basic values of tan. Tan theta, we need tan 0, tan 30, tan 45 degree, tan 60 degree and tan 90 degree. Okay, if you have the trigonometry table, you can easily find these values. Now tan 0, tan theta, if theta is equal to 0 degree, then tan 0 will be equal to 0. The value of tan 30 degree, tan theta, if tan 30 degree, then the value is 1 by root 3. Tan 45 will be sin 45 by cos 45. Sin 45 is equal to 1 by root 2. Cos 45 is also equal to 1 by root 2. 1 by root 2 by 1 by root 2, we get 1 as tan 45 degree. Next, tan 60 degree. Tan 60 degree is root 3. Sin 60 by cos 60, when you do, you get root 3. Now, tan 90 degree. We have sin 90 1 and cos 90 0. 1 by 0, which means it is not defined. Not defined. We got some basic values. Now, here in the first question, we have the slope given. Slope m is equal to 0. We have slope m is equal to tan theta. This is how we get slope. Therefore, here we have tan theta is equal to 0. What is 0? 0 is tan 0 degree. Yes. Therefore, we can write tan theta is equal to tan 0 degree. That is where we are getting tan theta equal to 0. Check from this. We get tan 0 is equal to 0. Now, we get theta is therefore equal to 0 degree. This theta is the inclination. Therefore, inclination, here inclination is equal to 0 degree. Okay, there is no vertical rise in this case. Next, the second one, we have slope m is equal to root 3. Slope m is equal to root 3. Okay, m is equal to tan theta. Same steps, we have m is equal to tan theta. Here tan theta is equal to root 3. Where do we get tan theta equal to root 3? Tan 60 degree is root 3. Therefore, we can write tan theta is equal to tan 60 degree. If tan theta is equal to tan 60 degree, we can write theta is equal to 60 degree, which means the required inclination is 60 degree when the slope is equal to root 3. Okay, that is just the reverse thing we are finding from the first question. The first question, we were given the inclination and we determined the slope. Here, slope is given and we are finding the inclination. Clear? Let's move on to the next problem. Next problem number 3, question 3 of exercise 14b. Find the slope of the line passing through the following pairs of point. In the first, second and third sub-questions, 2 points are given. That is, x and y coordinates of 2 points are given. Using this, we need to find the slope of the line which passes through these 2 points. Okay. The first question, we have points -2, -3 and 1, 2. Here, -2, -3 is the first point. We'll take the coordinates x1, y1. The second point is 1, 2. We'll take the coordinates x2, y2. So this is a line which passes through these 2 points. We are going to find the slope. What is the formula to find slope in this case when 2 points are given? Slope m is equal to y2 minus y1, that is the difference of y coordinates, divided by x2 minus x1, difference of x coordinates. Now put the values. M is equal to, here we have y2 is equal to 2 minus y1 is equal to minus 3. Minus 3 divided by x2 minus x1. x2 is 1 minus x1 is minus 2. Minus 2. That is equal to 2 minus of minus 3 is plus 3. 2 plus 3 divided by 1 minus of minus 2. 1 plus 2. Which is equal to 2 plus 3 5 divided by 1 plus 2 3. Therefore, here the slope m is equal to 5 divided by 3. Now, the second question. Here the coordinates are minus 4, 0 and the second coordinate is origin. What are the x and y coordinates of origin? Yes, 0, 0. X coordinate is 0 and y coordinate is also 0 for origin. So, this is the line which is passing through these 2 points. Let us take the first point, x1, y1. This is x2, y2. Now, to find the slope, slope m is equal to y2 minus y1 divided by x2 minus x1. You have to write this. Just putting the values and solving is not enough. You have to write the exact formula. To find slope when 2 points are given, we have m is equal to y2 minus y1 divided by x2 minus x1. If the angle or the inclination is given, we have slope m is equal to tan theta. Okay, now substitute the values. M is equal to, what is y2? y2 is equal to 0 minus y1 is also equal to 0. Divided by x2 minus x1. Here x2 is 0 and x1 is equal to minus 4. Minus 4. That is equal to 0 minus 0 is 0 divided by 0 minus of minus 4. 0 plus 4. We get 4 in the denominator. 0 divided by any number will be equal to 0. Here the slope m is equal to 0. Okay. Next, the third sub-question, we have points A minus B and B minus A. A minus B is the first point. Take them as x1, y1. B minus A is the second point. That is x2, y2. Now, slope is equal to, same step, slope m is equal to y2 minus y1 divided by x2 minus x1. That is equal to, m is equal to y2 minus y1. Here y2 is equal to minus a, y1 is equal to minus b. Minus b divided by x2 minus x1. x2 is equal to b and x1 is equal to a. B minus a. That is equal to, here we have minus a, minus of minus b is plus b divided by b minus a, which is minus a plus b is also equal to b minus a. Rearranging this, we get b minus a in the numerator and we already have b minus a in the denominator, which means the slope m is equal to 1. Here the slope m is equal to 1. Clear? So this is our third problem. Next, problem number 4, question 4 of exercise 14b. Find the slope of the line parallel to AB. First points are A is equal to minus 2, 4 and B is equal to 0, 6. Second, A is equal to 0, minus 3 and B is equal to minus 2, 5. For a line which is parallel to AB, the slope of AB and the line that is parallel to AB will have the same slope. Okay. That is, what are parallel lines? They are never intersecting lines. Now, if this is AB, then the line parallel to AB will never intersect with AB. It will be parallel. The distance between these two lines at every point that is considered perpendicular will be same. These are parallel lines. Okay. Now, to get the slope of a line that is parallel to AB, we just need to find the slope of AB. For the first question, we have points -2, 4 is A and B is 0, 6. So, this is a line that is AB. Joining A and B, we get this line. Now, how to find the slope when 2 points are known? We have m is equal to y2 minus y1 divided by x2 minus x1. Here, this points we take x1, y1. That is first points, and B will be x2, y2. Put the values. M will be equal to y2 minus y1. 6 minus 4. 6 minus 4 divided by x2 minus x1. Here x2 is equal to 0 and x1 is equal to -2. Minus of -2. That is equal to 6 minus 4, 2 divided by 0 minus of -2. 0 plus 2, again 2. 2 by 2 cancelling, we get 1. Here, therefore, the slope m is equal to 1. What is m? M is the slope of AB. Therefore, we can write slope of line parallel to AB is also equal to 1. Because we have slope of AB and the line parallel to AB of same slope. Clear? Now let us take the second question. Second, we have point A and B given. A is equal to 0, -3 and B is -2, 5. This is a line joining A and B. Let us find the slope of AB. We have slope m is equal to y2 minus y1 divided by x2 minus x1. Here what are x1, y1 and x2, y2? Point A we can take as x1, y1 and this is x2, y2. Now substituting the values, we get m is equal to y2. Here y2 is 5 minus y1 is -3 divided by x2 minus x1. x2 is -2 and x1 is 0, -0. That is equal to 5 minus -3. 5 plus 3 divided by -2. Therefore, m is equal to 5 plus 3, we get 8 divided by -2. Taking the negative to the numerator, 8 by 2 is 4. Therefore, here the slope is equal to -4. And we can write slope of line parallel to AB is equal to -4. So, for the first two set of points A and B, we got the slope of line that is parallel to AB as 1. And for the second set of point, we got the slope of line that is parallel to AB as -4. Clear? Next problem number 5, question 5 of exercise 14b. Find the slope of line perpendicular to AB. In the previous question, we found the slope of line which was parallel to AB. We know that for parallel lines, the slope will be same. Now, what about the case with perpendicular lines? We have 2 points given. First points, A 0 minus 5 and B -2, 4. Second, A is equal to 3 minus 2 and B is equal to -1, 2. Let us consider a line AB. This is line AB. A line that is perpendicular to AB. This is a line perpendicular to AB. Okay, we'll call it some L. This line L is perpendicular to AB. The angle between them will be 90 degree. Now, if you are taking the slope of AB is equal to some M1 and the slope of line L as some M2, then the product of the slopes m1 into m2 will always be equal to minus 1. We have studied this when I explained the concepts. Okay, m1 into m2 is equal to minus 1. We can find m1 when 2 points are given. What is m1? m1 is the slope of line AB. So take the first set of points. We have A is equal to 0, minus 5 and B is equal to minus 2, 4. We'll find the slope of this line AB. Slope of AB, m1 is equal to, same formula, that is y2 minus y1 divided by x2 minus x1. Now here point A coordinates are x1, y1 and point B coordinates are x2, y2. Put the values. m1 is equal to y2 minus y1, 4 minus of y1 is minus 5. Minus 5 divided by x2 minus x1. That is x2 is minus 2 and x1 is equal to 0. Minus 0. m1 is equal to 4 minus of minus 5. 4 plus 5, that is 9 divided by minus 2 minus 0 is minus 2. Taking the negative to the numerator, 9 by 2. What is 9 by 2? 9 by 2 is 4.5. Okay. Therefore, the slope of line AB, m1 is equal to minus 4.5 or minus 9 by 2. Now we need to find the slope of the second line, that is a line which is perpendicular to AB, and the slope of the line perpendicular to AB is taken as m2. Therefore, we can take this formula, that is m1 into m2 is equal to minus 1. Put the value of m1 which we got here. Let us put the value, that is minus 9 divided by 2. Okay, I am not taking the decimal part, I am taking the fraction. Minus 9 by 2 into m2 will be equal to minus 1. Keep m2 in the left hand side and take all other term to RHS. That is minus 1 into. Taking this to the opposite side, we have to take the reciprocal and multiply. Here we have minus 9 by 2. Then it will be 2 divided by minus 9. Negative and negative can be removed. Therefore, the slope m2 will be equal to 2 divided by 9. Which is the slope of line perpendicular to AB is equal to 2 divided by 9. So when you get the slope of line AB, we can easily find the slope of line which is perpendicular to AB using this relation, that is m1 into m2 is equal to minus 1. Here m1 is the slope of AB and m2 is the slope of line perpendicular to AB. Understood this? Now the second set of points, we have A 3 minus 2, 3 minus 2 and B minus 1, 2. This is the line AB. We need to find the slope of the line that is perpendicular to AB. Okay. We have slope of AB, m1 is equal to y2 minus y1 divided by x2 minus x1. Put the values. Here we have x1, y1. Here we have x2, y2. That is equal to y2 minus y1. y2 is 2 minus y1 is minus 2 divided by x2 minus x1. Minus 1 minus 3. x1 is 3. That is equal to 2 minus of minus 2. 2 plus 2 divided by minus 1 minus 3 minus 4. That is 4 divided by minus 4, which is equal to minus 1. Okay, we got m1 is equal to minus 1. Now how to find m2? We have m1 into m2 is equal to minus 1. Putting the value, m1 is minus 1. Minus 1 into m2 is equal to minus 1. Which means m2 is equal to minus 1 divided by minus 1. Minus 1 by minus 1, and that is equal to 1. Therefore, slope of line perpendicular to AB is equal to 1. Okay. Now you know to find the slope of line perpendicular to AB and the slope of line which is parallel to AB. You will be able to solve questions, right? Next, problem number 6, question 8 of exercise 14b. Without using the distance formula, show that the points A 4 minus 2, B minus 4 4 and C 10 6 are the vertices of a right angle triangle. What are the peculiarities of a right angle triangle? When does a triangle become a right angle triangle? For a right angle triangle, the one angle will be equal to 90 degree. Only then we will be calling it a right angle triangle, and the side opposite to this 90 degree angle will be the longest side, which we call the hypotenuse. Okay, now we are considering a triangle ABC. We should show that this is a right angle triangle. Let us take the coordinates. A coordinate is 4 minus 2, B coordinate minus 4 4 and C coordinate 10 6. Okay, now when it comes to right angle triangle, you will be having a hypotenuse, you will be having a base and a height. Here we don't know which is a base, which is a height and which is a hypotenuse. How to prove this is a right angle triangle? We know for a right angle triangle, one angle will be equal to 90 degree. That is, if you are taking these two sides, the angle between these two sides are 90 degree. Which means the slope, if you are taking this slope of this side as M1 and slope of this side as M2, M1 into M2 should be equal to minus 1 because they are perpendicular for a right angle triangle. So by finding the slope of AB, BC and AC, if we are getting, we will be taking the slope of AB as some M1, slope of BC as some M2 and slope of AC as M3. By finding M1 into M2 or M2 into M3 or M1 into M3, if we are getting minus 1, then the two sides will be perpendicular. If we have two sides perpendicular, then it will be a right angle triangle. Okay. First, let us find the slope of AB, which is M1 is equal to y2 minus y1 divided by x2 minus x1. Here we are taking these 2 points as x1, y1 and these 2 points as x2, y2. Okay, what are the coordinates? y2 is 4 and y1 is minus 2. 4 minus of minus 2 divided by x2 minus x1. Here x2 is minus 4 and x1 is 4. Minus 4 minus 4. That is equal to 4 minus of minus 2. 4 plus 2 which is 6 divided by minus 4 minus 4. Minus 4 minus 4 is minus 8. Okay. This is equal to, taking negative to the numerator, 6 divided by 8 is 3 by 4. So we got M1 is equal to minus 3 by 4. Now let us find the slope of BC, which is M2. Again, y2 minus y1 divided by x2 minus x1. Here we will be taking the coordinates of C as x2, y2 and the coordinates of B as x1, y1. Put the values, we will be getting M2 is equal to 6 minus 4 divided by 10 minus of minus 4. That is equal to 6 minus 4, 2 divided by 10 minus of minus 4. 10 plus 4 which is equal to 14, which is 1 divided by 7. We got M2 is equal to 1 by 7. Next, we need M3, that is slope of AC. M3 is equal to, again, y2 minus y1 divided by x2 minus x1. Here I am taking x1, y1 as this point C and x2, y2 as this point A. Putting the values, here we have minus 2 as y2, y1 is 6. minus 6 divided by x2 minus x1. Here x2 is 4 minus x1 is 10. That is equal to minus 2 minus 6 minus 8 divided by 4 minus 10. 4 minus 10 is minus 6. Negative and negative can be removed. Taking the fraction dividing by 2, the numerator and denominator, we get the fraction 4 divided by 3. Okay, we got m3 is equal to 4 by 3. So we have m1 is equal to minus 3 by 4, m2 is equal to 1 by 7 and m3 is equal to 4 by 3. Let us multiply m1 and m2 first. If we are getting minus 1, then these two sides, that is AB and BC, will be perpendicular. m1 into m2 is equal to minus 3 by 4 into m2 is 1 by 7, which is equal to minus 3 divided by 4 into 7 is 28. We are not getting minus 1. Therefore, these two sides, that is AB and BC, are not perpendicular. Next, we will take m2 and m3. m2 into m3. That is equal to m2 is 1 by 7 into m3 is 4 divided by 3. 4 by 3, which is equal to 4 divided by 7 into 3, 21. Here also we are not getting minus 1, which means BC and AC are not perpendicular. Next we will be taking m1 and m3. m1 into m3. That is equal to m1 is minus 3 divided by 4 into m3. m3 is 4 divided by 3. 4 by 3. 3 gets cancelled. 4 gets cancelled. We have minus 1. Here we are getting minus 1. That is slope of AB into slope of AC is equal to minus 1. Which means AB is perpendicular to AC. We got two sides perpendicular and therefore triangle ABC is a right angled triangle. ABC is a right angled triangle. Okay. Here we'll be having AB and this is AC. These two sides, that is AB and AC, are perpendicular to each other and this triangle is a right angle triangle. Clear? We need to find the slope of the three sides and find m1 into m2, m2 into m3 and m1 into m3. If we are getting minus 1, then those two sides will be perpendicular to each other. Clear? Next, problem number 7, question 9 of exercise 14b. Without using the distance formula, show that the points A4, 5, B1, 2, C4, 3 and D7, 6 are the vertices of a parallelogram. What are the peculiarities of a parallelogram? For a quadrilateral, if the opposite sides are equal and parallel, then we call it a parallelogram. I am taking a parallelogram naming A, B, C, D. Okay. If this is a parallelogram, then AB will be parallel to DC and AD will be parallel and equal to BC. Okay. By finding the slopes of all the sides and checking if the slopes of two sides are equal. If the slopes are equal, then the sides will be parallel. We'll find the slope of all the four sides. Here we have points A, coordinate 4, 5, B coordinates 1, 2, C 4, 3 and D 7, 6. Okay, first let us find the slope of AB, which is taken as M1, is equal to y2 minus y1 divided by x2 minus x1, which is equal to y2. What is y2? Y2 is the y coordinate of point B. Here we have 2 minus y1 is 5 divided by x2 minus x1. x2 here we have 1 and x1 is 4. 1 minus 4, that is equal to 2 minus 5 is minus 3 divided by 1 minus 4 is again minus 3, which is equal to 1. Minus 3 by minus 3 is 1. Therefore, we have slope of AB is equal to 1. Next, we'll find the slope of BC. Taking slope of BC, M2. Formula y2 minus y1 divided by x2 minus x1. Here, I am taking B as x1, y1 and C as x2, y2. Putting the values, we get M2 is equal to y2 minus y1. 3 minus 2. 3 minus 2 divided by x2 minus x1, 4 minus 1. 4 minus 1. That is equal to 3 minus 2 is 1 and 4 minus 1 is 3. We get slope of BC M2 is equal to 1 divided by 3. Now we need to find the slope of next side CD. Slope of CD. We take it as M3. That is equal to again y2 minus y1 divided by x2 minus x1. Here I am taking C as x1, y1 and D as x2, y2. Therefore y2 is 6 minus y1 is 3 divided by x2 minus x1. x2 is 7, x1 is 4. 7 minus 4. That is equal to 6 minus 3. 6 minus 3 is 3. 7 minus 4 is also 3, which is equal to 3 by 3, 1. Next, slope of the last side, DA or AD. Slope of DA, M4 is equal to, here I am taking the coordinates of D as x1, y1 and coordinates of A as x2, y2. y2 is 5 and y1 is 6. 5 minus 6 divided by, here x1 is 7 and x2 is 4. 4 minus 7. That is equal to 5 minus 6 is minus 1 divided by 4 minus 7 minus 3. That is equal to 1 by 3. Okay, so we got the slope of AB, slope of BC, slope of CD and slope of DA. When you check these values, we'll find the slope of AB is 1 and also the slope of CD is 1. That is, we have M1 is equal to M3. Similarly, we are getting the slope of BC as 1 by 3. Slope of DA is also equal to 1 by 3. M2 is equal to M4. From which we understand that since the slope of AB and CD are equal, these two are parallel lines. Okay, we can write AB parallel to CD. Also we have the slope of BC equal to slope of AD. Therefore, BC is parallel to AD or DA. Since the opposite sides are parallel, we can call this quadrilateral as a parallelogram. Therefore, our required quadrilateral ABCD is a parallelogram. ABCD is a parallelogram. Clear? So here we have not used the distance formula. We are just calculating the slopes of each side and getting equal slopes for opposite side. We proved that this figure given is a parallelogram. Understood this? Let's move on to the next problem. Problem number 8, question 11 of exercise 14b. Show that the points P, A, B plus C, Q, B, C plus A and R, C, A plus B are collinear. Okay, what are collinear? Points. If you take 3 points, if these points lie on the same straight line, we call them collinear points. Here we have P, Q, R of coordinates A, B plus C, B, C plus A and R, C, A plus B. If they are collinear, they lie on the same straight line. Okay. Now we have to show that these points lie on the same straight line. If I am taking this part PQ and this part QR and finding the slope of these two, if I am getting equal slopes, then I can say that these 3 points lie on the same straight line. Because PQ and QR, if they are having same slope, they will be on the same straight line, or they should be parallel lines. So parallel lines cannot be considered here because we have a common point. I am taking this Q as a common point. Let us take the slope. We cannot say that this is in the same order like P, Q, R. By finding the slope, if we are getting the slope of PQ equal to QR, or slope of PR is equal to slope of QR, or the slope of QR is equal to slope of PQ, we can say that they are collinear points. First, let's find the slope of PQ. Slope of PQ is equal to y2 minus y1 divided by x2 minus x1. Here I am taking these 2 points. These coordinates of P as x1, y1 and coordinates of Q as x2, y2. Putting the values, C plus A is y2 minus y1 is B plus C. B plus C divided by x2 minus x1. x2 is B and x1 is equal to A. B minus A. That is equal to C plus A, removing the bracket and distributing the negative sign, minus B minus C, divided by B minus A, and that is equal to, cancelling C and minus C, we have A minus B divided by B minus A, which can be written as A minus B is minus B minus A. Okay, I am taking a negative sign outside, divided by B minus A. Cancelling B minus A and B minus A from the numerator and denominator, we get minus 1. Therefore, the slope of PQ is equal to minus 1. Now, let us find the slope of QR. Slope of QR is equal to, again, y2 minus y1 divided by x2 minus x1. Here I am taking the coordinates of R as x2, y2 and coordinates of Q as x1, y1. Putting values, y2 is A plus B minus y1 is C plus A. C plus A divided by x2 minus x1. Here x2 is C and x1 is B. C minus B. That is equal to A plus B minus C minus A. Removing the brackets and distributing the negative sign, divided by C minus B, which is equal to, cancelling A and minus A, we have B minus C divided by C minus B. Same step, taking negative outside from the numerator, we get minus of C minus B divided by C minus B. We are doing this to cancel the C minus B. C minus B can be cancelled, which means here the slope of QR. Slope of QR is equal to minus 1. Therefore, we are getting slope of PQ is equal to slope of QR. And we can conclude that P, Q, R lie on the same straight line. Since these points lie on the same straight line, they are collinear points. They are collinear. Okay, these points are collinear. Understood? We just need to find the slope using the points. Problem 9, question 16 of exercise 14b. The slope of the side BC of a rectangle ABCD is 2 by 3. Find the slope of side AB and the slope of side AD. What is a rectangle? When do we call a quadrilateral a rectangle? For a rectangle, we are taking ABCD as this quadrilateral. For a rectangle, opposite sides will be parallel and equal. Then it is a parallelogram. Now, when does it become a rectangle? All the angles becomes equal to 90 degree. For a parallelogram, if the quadrilateral is a parallelogram, and for this parallelogram, if all the angles becomes equal to 90 degree, we call it a rectangle. Okay. Now, Here it is given that slope of BC is equal to 2 divided by 3. Okay, here we have BC and the slope of this BC is given, which is 2 by 3. Now when you consider this rectangle, we can understand that AB is perpendicular to BC. Yes, here we have 90 degree, therefore side AB is perpendicular to BC. And we can say AD is parallel to BC. Also, CD is perpendicular to BC. I am comparing all the other sides with BC because BC, the slope of BC is not. We need to find the slope of AB and slope of AD. First, let us find the slope of AB. AB is perpendicular to BC. Okay, I am taking slope of BC as M1 and M1 is equal to 2 by 3. Let the slope of AB is M2. Okay, when two lines are perpendicular, the slopes M1 into M2, the product of the slopes M1 into M2 will be equal to -1. Here we have M1 is equal to 2 by 3. Therefore, 2 by 3 into M2 we don't know, M2 is equal to -1. We can find M2 from here. M2 will be equal to -1 into the reciprocal of 2 by 3. Reciprocal of 2 by 3 is 3 by 2. Therefore, M2 is equal to -3 by 2. That is, slope of AB is equal to -3 divided by 2. Okay, this is the answer for your first question. Now, the second part, we need to find the slope of AD. AD or DA. AD is parallel to BC, which means they will be having equal slopes. Slope of AD, let me take it as some M3. Okay. What is M3 then? The value of M3 will be equal to that of M1 because they are parallel lines. M1 and that is equal to 2 by 3. Therefore, slope of AD is equal to same as the slope of BC and that is 2 by 3. Clear? Okay, we got the slope of AB and the slope of AD. AB is perpendicular to BC and AD is parallel to BC. Understood this? Let's move on to the next problem. Here we have the last question for today, problem 10, question 18 of exercise 14b. The points -3, 2, 2, -1 and A4 are collinear. Find A. Here it is given that these three points are collinear. We need to find the value of A. For collinear points, when you take the slopes of different points, we'll be getting them equal. Here we have points -3, 2, second 2, -1 and A4. Since these are collinear points, they lie on the same straight line. Let us name them as some points A, B, C. I'm going to find the slope of AB and slope of BC. Slope of AB, M1 is equal to, here we have this point as x1, y1 and this point as x2, y2. y2 minus y1 divided by x2 minus x1. That is equal to y2 is -1 divided minus y1 is 2 divided by x2 minus x1. x2 is 2 minus x1 is -3. That is -1 minus 2 minus 3 divided by 2 minus of -3. 2 plus 3, that is 5. -3 divided by 5 is M1. That is slope of AB. Next, we'll find the slope of BC. Slope of BC is equal to, here we have x coordinate of point C as A. y2 minus y1 divided by x2 minus x1. Let us take this as some m2. m2 is equal to, here this is x1 y1 and this is x2 y2. y2 is 4 and y1 is minus 1. 4 minus 1 divided by x2 minus x1. Here we have a and 2. a minus 2. That is equal to, m2 is equal to 4 minus 1, 4 plus 1 divided by a minus 2. Since these are collinear points and they lie on the same straight line, we will be getting the slope equal. m1 is equal to m2. We have m1 is equal to minus 3 by 5. And what is m2? m2 is equal to 5 divided by 4 plus 1, 5 divided by a minus 2. 5 divided by a minus 2. What to do next? We need to find the value of a, the variable a. Cross multiplying, minus 3 into a minus 2 is equal to 5 into 5. Here, removing the brackets and multiplying, we get minus 3a. Minus 3 into minus 2 is plus 6 is equal to 5 into 5, 25. Or minus 3a is equal to 25. Taking this plus 6 to the opposite side, it becomes minus 6. Minus 6. Minus 3a is equal to 25 minus 6. 19. Then what is a? A is equal to 19 divided by minus 3. Taking the negative to the numerator, we get a is equal to minus 19 by 3. If we are converting it into fractions, this fraction into decimal, we get minus 6.333. A is equal to minus 6.333. Okay, understood this? Here in this question, points given are collinear. We are finding the slopes and then finding the value of a. That's all for today. In today's class, we have discussed about slopes, gradients, inclination, slope of parallel lines, slope of perpendicular lines and collinear points. Hope you all enjoyed this section. We have understood all the concept with many examples and solved many questions from exercise 14b. There are a few more questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.